Okay, guys, so we're going to look at arithmetic sequences, and arithmetic is, having to do with numbers and math, and then sequences, numbers that are in a particular order. So I've got a real, well, not basic, but here's an arithmetic sequence right over here, and we're going to talk about two things really: writing an equation, an explicit equation for an arithmetic sequence, and then being able to maybe solve for a specific term of an arithmetic sequence. So this will be what we use for our first example, and you could probably see from here and maybe figure out what the sequence is going up by. But let's define an arithmetic sequence real quick and make sure that we have that. So an arithmetic sequence is a sequence of numbers which increases or decreases by a constant amount. So we're looking for basically an addition or subtraction amount within the sequence. So if we go back to our numbers right over here, while you're getting that down, I think it's pretty straightforward, but this is going up each time. We're going up by 5 each time. So that is going to be part of the arithmetic sequence as we go to write an equation and then maybe solve for a term that's a little bit further down. So make sure you have that down again. Arithmetic sequence, a sequence of numbers which increases or decrease, or which increase or decrease by a constant amount. Arithmetic sequence. So let's talk about writing the equation here. So this is going to be our explicit equation form for an arithmetic sequence. It's, a of n equals a1 plus, we've got n minus 1, and then outside the parentheses we've got a d right there. And obviously this looks like a lot, but once we start working with it, it'll all kind of fall into place. So let's kind of define what each of these things kind of stand for within the sequence. So let's start with the first value at any rate, the a of n. We're basically talking about this right over here, the a of n. This is just going to refer to the number of terms we're solving for. So this is going to be the number of terms. I'll just handwrite it in. The number of terms and I'll use u for you who are working on it. So number of terms you are solving for. Try to make this as legible as I can real quick. So this is going to be the a of n, and that actually is gonna anywhere we see an n, so we've got an n right there, and then the same thing for this n right here I just underlined. So same thing right here, that's going to be the number of terms that we're solving for in our question or our word problem, and we'll look at an example of that in just a second. The next thing is that a of 1. So we've got that a of 1, and this is just going to be the first term in our sequence. So we're going to define this as basically, what does that stand for? The first term in the sequence. So first term in the sequence, to make that a little bit better, E right there. There we go. And then lastly, we're going to leave that minus 1 alone. The last thing is the D out over here on the N, and this is going to stand for the common difference. So when we find, kind of like we did earlier, we're going to find the common difference in our sequence, and that value is going to go there. So I'm just going to write common difference. And make sure you have this down, because once you kind of have all this info, makes it pretty easy to plug these in, and then we can get the equation written and then solve for a term. Alright, so let's put this to use, and let's try it out with that sequence we started with real quick. Okay, so I've got the a of, we kind of have it, our equation at the top. So let's look at this right over here. So we're going to use the 1, 6, 11, 16, and let's start filling in for the value. So here's what we're going to do. So we're going to start with our a of n, so we're just going to write this down, maybe a little bit to the left to give some space. So we've got our a of n value. That's going to equal, we're going to write the equation first. So I'm just going to write this out over to the side, that we're going to go ahead and write the explicit equation first, okay? and that's what we're going to start with, and then we'll solve for something in just a second. So let's put this in an equation, all right, for our sequence. So the a of 1, remember, the a of 1 right over here is going to be our first value, our first term, okay? Well, our first term is right over here. It's a 1. All right, it's not always going to be a 1, but in this case, it's a 1. So let's put that in real quick. So the first term is a 1, and it's going to be 1 plus, we're going to open up the parentheses. We're going to leave this as n minus 1. We're not going to change anything when we write the equation. And then we just need to get this value for the d filled in right over here. Well, that's going to be the common difference. What is the common difference? We talked about this right at the beginning. What are we adding or subtracting from 1 to 6, from 6 to 11, from 11 to 16? Well, we're doing plus 5. We're doing a plus 5 everywhere here. And it can be subtraction. Sometimes we want to make sure we get that right. So we know it's plus 5. I'm going to back out just so we have some space. So I'm just going to put a 5 over here for the common difference. Okay, check this out. We kind of wrote the equation, but we want to simplify this down, okay? So what I mean by simplifying is we can take this 5, like we've done before, and we can actually distribute it, because it's being multiplied, into the parentheses, okay? So watch how I do this. So I still got my a to the n power here. It's still going to equal my positive 1 plus, but inside the parentheses we're multiplying. So I'm doing a 5 here, 5 times n. Well, 5 times n is just going to get you, I'll do this in green, 5n. And then I'm doing 5 times 1, but it's a negative 1, that negative in front of there. So it's going to be minus 5 or a negative 5 once we distribute. All right, we've almost simplified this down, but we can combine a couple of like terms here, okay? I've got a 1 here, and then I've got a minus 5 or a negative 5 there. Well, we can actually do some math there. We can do 1 minus 5. So I can simplify this equation all the way down by doing this. I can do a of n equals. I'm going to go ahead and put the 5 in with the variable first. And then we're going to do this part over here where we did the, I'll just do it in parentheses, where basically we're doing a 1 minus 5 from these values right over here that I have underlining gray. Well, 1 minus 5 is negative 4. So I'll write that out here in orange, minus 4. And then check it out. We actually have the full, the explicit equation completely simplified all the way down to a of n equals 5n minus 4. So we've got the equation done. That looks good. What you can do after this is you can actually solve for a term, kind of a future term, what they call kind of an nth term as we go up a move. So what we're going to do is now we're going to plug in a value. We're going to solve for the 11th term, the 11th term. So what that means is, so far we have 4 of them, right? They give us 4 terms in this right over here, 1, 2, 3, 4. We're going to use this equation to figure out what the 11th term will be all the way down, okay? So I'm going to go to this fresh screen right over here. I'm going to write in this equation. So I'm going to put the a of n equals 5n minus 4. You should kind of already have it. So a of n, a little smaller, a of n equals, I got 5n minus 4. Make sure we have this. I'll do that in green. 5n minus 4. We're going to solve for the 11th term. We're going to figure out what the 11th term in the sequence is. So I'll do a little 11 out here so we understand that. The 11th term. All right, cool. Well, all we need to do now is basically, if we're going to solve for the 11th term, we do a of 11 equals, so anywhere there's an n, we just plug in the 11. So I have a 5 here. Instead of that n, I'm going to go ahead and I'm going to plug in 11 there. And we could do the same thing. We could solve for the, sorry, I'm going to write that a little neater, but we could solve for the 5th term or the 20th term or whatever. Whatever we solve for, we just plug it in and we do the math, okay? Now, let's just do the math on this thing. So the a of 11 term is going to equal 5 times 11 here, when I do the math, it should get me 55. And we get that to 55 minus 4. Well, a of 11 is going to equal 55 minus 4, which is 51. So the 11th term, if we wanted to figure that out, would be 51. If I started with the 1, 6, 11, 16, all the way down to the 11th term right over there, that would be 51. Okay, so we wrote the equation, the explicit equation, and then we plugged in a value into that equation to solve for a term that we were asked to solve for. Let's try another one real quick. I'll kind of go a little bit faster. So we've got a different sequence. We've got our explicit equation up at the top set up. Well, let's start filling things in real quick. Let's write the equation first, and then we're going to solve for one of the terms. Let's see which one I'm going to solve for. We'll probably come in and solve for the 19th term, but I'm going to come in and we'll do that second. But I'm going to write down a 19 up here because that's probably the 19th term we'll solve for. All right, so let's start filling in our equation. Well, we know we have a to the n power equals. The a1 is our first value. Well, in this case, it's a 30. So let's put a 30 in there, guys. 30 plus. Remember, when we're writing the equation, we keep the n minus 1. We don't need to do anything to that yet until we get to the part where we distribute the difference, the common difference in. We're at the common difference. Well, what is the common difference? What's happening from 30 to 26, from 26 to 20? We're subtracting, actually. We're actually going down by 4, okay? So if I switch this out, looks like we're going down by 4 each time, down by 4. So I've got to put a negative 4 out here. Okay, that's going to be my common difference is negative 4. Yeah, it can be negative, just like it was positive in the last one. All right, let's simplify it down. We still have a of n. We're not solving for any terms or anything yet. I've got 30. 30 plus. This is where we distribute. Okay, so if you recall from the first example, this is where you come in real quick. Come in with gray. Distribute the negative 4 to the n. So that's going to get negative 4 in, and we'll clean that up in just a second. And then we do the negative 4 times the minus 1 or the negative 1. A negative times a negative is a positive. So that should get us a plus 4 hanging out right over here. Okay, I just distributed the negative 4. All right, we can simplify one more time to get this all the way down to the explicit equation. That's going to be a of n equals 30 plus, let me back up. Sorry, I don't need to do that. We're going to actually add. Let's add. We've got the 30 plus 4. We can do the 30 plus 4 right over there. So let me bring the negative 4 in here. Negative 4 in. I'm just bringing it over. Let's do the 30 plus 4. Well, 30 plus 4 is 34. And that's what we got right over here. I've got a of n. The ace of n, I guess, is equal to negative 4n plus 34 as our explicit equation. And now we can solve for the 19th term. So we're going to solve for the 19th term all the way down there. Well, how do we do that? We just take this 19 that I'm boxing in here and we put it in for the n value. So it looks like this. So we're going to go, and I'm going to kind of box in the equation just so we make sure we know what the equation is. There it is. All right, let's solve for the 19th term. So that's a of 19 is going to equal negative 4. And I'm saying a, it's actually ace of 19, but kind of putting that in there for you guys here. We want the 19 here. And then we're going to put plus 34 right after that. And then we just do our math, all right? So ace of 19 out over here is going to equal negative 4 times 19. Negative 4 times 19, you can do it on paper or calculator it, but you're going to get a negative 76. So negative 76. A negative times a positive is a negative. We're going to add 34 to that. So we finish up saying, hey, ace of 19 is negative 36, or negative 76 plus 34. Negative 76 plus 34. You could calculate that too, but you're going to get negative 42. And that is going to be the answer right there to your 19th term. 19th term would be negative 42. If we continued this sequence right over here and got all the way down to the 19th term, negative 42. All right, last example. I'll do one more real quick just with some negatives. What if we had a negative 23, negative 18, let's go with negative 13, and then how about negative 8? So write those down real quick. So let's do the same thing. We have our explicit equation that we can fill in. It's ace of n, that's going to equal the initial value, so it's the starting term or the first term right over here, which is negative 23, plus, open up the parentheses for that n minus 1. So n minus 1, a little neater, I think. N minus 1. And then what's the common difference? What's happening? Well, negative 23 right over here to negative 18, it's actually a difference of 5. And it's a positive 5 since we're kind of going back. So you're going to just have a 5 in there. All right, let's get the equation written real quick, and then we can solve for one of the terms. I'll put one of the terms in, and we'll solve for that also. So a sub n equals negative 23 plus, and let's distribute here. So we've got to do 5 times n first. That's going to be 5n. So that gives us a 5n positive, and then a 5 times negative 1 right there. Well, that's going to get us a negative, minus 5, I should say. Minus 5. All right. We can combine some like terms here and continue to simplify. I'm going to list the 5n first. We always want our variable to come first. I've got negative 23 minus 5. Negative 23 minus 5 should be negative 28. And the explicit equation is written. It's good to go. We're good. And you might be asked to stop there. That might be the end of what we need to do. But we're asked to solve for the 13th term. So let's figure out what in orange, the 13th term is right here, the 13th term. So let's input a 13 here. So a sub 13 is going to equal 5. Let's input the 13 right over there. And then subtract away the 28, and we'll be good to go. All right. Moving a little quicker right over here. A sub 13 equals 5 times 13 should get you 65. So 65, you can calculate that if you want, or just skip count your 5. 65 minus 28 should get us our final value, or our term, our 13th term in this sequence. 65 minus 28, you subtract that out, you're going to get 37. So the 13th term in this sequence, if it continued, would be 37. So just reviewing, making sure we got our arithmetic sequences, writing the explicit equation, and then solving for a given term. And equation right over there, form, written down on your paper. And thanks for watching, gentlemen.